All right, here we go. Well, it didn't launch a valve into the neighbor's property, so I guess we're good. Hey folks, welcome back to another video. Today I'm wearing dark glasses because, well, I can. And now that I've straightened you out on that point, let's get to the business at hand. This is video 2 on the 1980 KZ1000 Mark II. I'm going to tell you right up front, this is going to be a long video. This video is really a video on problem solving and my thought process in working through different problems, primarily with this cylinder head right here to my left. So again, I'm going to go into some great detail on how we're solving problems in regards to the valves and the install valve height issues on this cylinder head. I'm going to bring you up to date on the bike itself first. Show you what we did in regards to the jug and all that stuff and the installation of that and so forth. I don't shoot that in detail, but I want to show you the finished product at least. But the primary thing is on this head here and the problems that we had with it, that I've had with it. And it's been going on for about 3 months now that we've been working on this bike, all right? I've also been really sick. The wife's been really sick and haven't been able to do a whole lot. So I apologize that we haven't been able to put a whole lot of content out. But we're making up for it with this one because there's going to be a lot of content in this. I do some things in this video that are probably not kosher looking as, you know, engine builder standards. You know, engine building is kind of like, you know, people get passionate about it. I'm not an engine builder. I never professed to be an engine builder. I don't want to do any engine building. The only thing I would do is rebuild something stock. Unfortunately, I get stuck with these kind of situations somebody else worked on, and now I got to work through the issues of trying to get it back together again. We had some outside help with a machine shop out of state, which I'll cover in this video, and I also consulted some professionals in the engine building racing world from American Performance Engineering, APE, and that's really going to be the source of the solution on this. But again, it's going to be a long video. I hope you enjoy it. If you don't like these, I'm sorry, but don't go watch something else. It's fine with me. Skip toward the end. Hopefully you're going to see the engine running. But for you guys that like to look through my eyes in regards to identifying and solving problems, this is a video for you. So let's go ahead and just get right to it. This has been sitting in this status for about a month and a half now. When I took the cylinder head off, if you look at video 1, that's pretty much where I left off. The cylinder head was sitting over there on the side of the lift. And we were talking about different aspects of whatever I was talking about. I don't even remember. It doesn't matter. That's when I noticed the issues with the cylinder head, which is over there, which I'll get back with you here in a second. As far as the cylinder block and installation goes, this is all done. I did all this off camera because I really didn't think it was all that interesting and it's kind of tedious anyway. I got it all back together and my intention was to slam the cylinder head back on after I did some more cleaning and testing and get this thing going. But this came out okay. I just have some spacers here with with 4 of the nuts. You said nuts. And just to hold it flat, there are 2 idlers, excuse me, one in the rear, sandwiched between the cylinder block and the cylinder itself, and then one in the front, same thing. And there are little rubber dampers that pinch those down between the 2. And I put new dampers in, so they're nice and springy. So what happened was if I didn't cinch this down a little bit, it would kind of want to lift it up a little bit and keep it off. And I wanted everything nice and flat. So I just cinched these down finger tight basically, just to keep it flat. And that's just where it's at right now. So nothing's bound up in here. And you can rotate these motors around. Obviously you have to get it back on top dead center. You can do that without any cams in. You just have to, according to service manual, you just take and secure or, hold up the timing chain and you can bar it over from motor here turning clockwise. And of course I did that after I put the block in with these guys on. That was another reason for doing it. So I could make sure everything was free and nothing was binding. So this is why I did it this way. And this is where we're at. I mean, there's not much more to explain on this. The main problem with the cylinder head, as you can see from these pictures, is on the intake valves, the valve guides, where they penetrated down through the bosses, that goes from the bottom of where the spring seat is on the top side of the head, down through toward into the combustion chamber. Those were blown out on 3 of the intake valves. So what appears to have happened is when the engine builder in 2021 put this together, he either used too large of intake valve guides or incorrect installation or a combination of things, and broke that out. So we had to deal with that somehow, and just I took a look at it and contemplated doing some work myself, but just couldn't exactly come up with a good plan. So the customer and I talked, and we decided to ship the head out to a machine shop, an engine machine shop, to have it repaired. We got ourselves a box. Let's go take a look at what's in the box. Inside the box is a cylinder head for this bike. I did some searching online. I chose this place, Arnell Engines. They're up in Dover, New Hampshire. And I really didn't get any responses from anybody else that I sent emails out to that said that they would do it. They were the only place that said that they would do it. But it's an engine machine shop, which are few and far between down here. Pretty much extinct in my area. And I emailed a few places that I have worked with before, like in Orlando. One place didn't even respond, and I even called them 2 times to try to get through to them and couldn't do it. I said, you know what, I'm just going to shoot it around different machine shops that I find online that look good. Arnell was one of them. They said that they would do it. I boxed the head up, shipped it up, and that was well over a month ago. All right, we're looking at the intake side over here. Hope this doesn't give me a flicker effect, but let's look at number 2, which was the worst. So what they ended up doing was they ended up popping the valve guides out and just essentially removing the material that was getting ready to come out. So if I do a side-by-side here with number 2 on this one, before and after basically, you can see the difference. And this is number 1 over here. That had some, problem, not a significant amount. And this is number 3 over here. That one looks pretty good, actually. There was really only 2 of them. I think 1 and 2 were the worst that had a problem. So those actually look pretty good. And the exhaust valves, and the exhaust guides rather, didn't have any problem at all. So the repair went pretty well as far as I'm concerned. So what the machine shop did, in summary, was drove out all the valve guides, intake and exhaust, cleaned this up to make sure that there was no loose pieces. There's plenty of meat left in there, according to what they told me, to push in, drive in new valve guides, no problem. He said he's dealt with this before, and there's going to be no problem with it. And there's plenty of meat in there. The original valve guides, he said, were too big, was what caused this. Because when he popped the intake valve guides out, he immediately measured the bores, measured the guides that came out, and said they were about a 2.5 thou crush on them, which is way too much, which is why they broke out. Why the engine builder put too large of intake valve guides in, I do not know. I think they had to ream the holes to clean them up, and then they installed even more oversized valve guides. They had to order them. They had to special order them directly from Kibblewhite, and got those in, and then had to order a special reamer. That was one of the delays. He didn't have a special reamer for these. Once they got them all reamed out, what he wanted to do was he wanted to set them up for these valves, which is the ones that I sent with him, the original valves. He also reconditioned or essentially realigned the valve seats for those particular valves, because once you put valve guides in, you have to redo the seats because they're no longer concentric. And, pretty much that's it. That's really all he did. But it took, quite a long time to do it. You can see the valve guides on the exhaust side are in, which are, pretty much standard as far as that goes. And we don't really have any problems with those. And again, he did the same thing with the valves and the valve seat cutting on this side. So that's pretty much it on the work the machine shop did on the cylinder head. I mean, it's not a lot of material that was lost, only a little bit. But the problem with that was the material was so cracked and just, it looked like it was getting ready to break off. And that's on the intake side. That gets sucked right into the engine. So the customer said he wouldn't be comfortable with leaving it the way it was, which is what the engine builder told him. And when I discovered this, I emailed the customer pictures. He emailed them to the engine builder. Took him a week to get back to him. He forwarded me the message that said, oh, well, I take great care basically in removing and reinstalling valve guides, but in the end, sometimes they still crack. That's a bunch of BS. So he wasn't going to do anything for us, so we had to do it ourselves. And I think that was a pretty good solution. All right, folks, we're over here on Dad's old bench. And we do have one small problem with this head. And I'll show you what that is here in a moment, but I want to explain to you the various things that needs to be done when you're doing a cylinder head like this as far as reassembling it to make sure that all the specs are correct. In particular, the installed valve height. So here's number 3 exhaust valve, and you can see that Engine builder, he did touch these up on a valve grinder and also touch the end. So here's the standard for installed valve height. Now the importance of installed valve height on these engines speaks directly to valve clearance. So this is essentially the range that you have for valve clearance with shims. So for example, up here, if you have this kind of stick out as far as the top of the valve to the bottom of the bore where the spring seat sits, and that's essentially the measurement there. So from the top here to the spring seat. If it was way up here, it essentially would be pretty, short as far as stuck down in there compared to if it was down here. So this is taller and this is shorter. If it's shorter, it needs a bigger shim because the cams, of course, are in a fixed position. So the cams, and then the buckets, the shims underneath that, then the buckets over top of the springs, and there's a little nipple, if you will, a little button on the bottom of the bucket that hits the top of the valve. What we have to do is, what we really would like to see is a installed valve height that's in this range right here, and typically 2.5, 2.55, 2.60 is about what I normally see, sometimes a 2.40, which is about in the middle here. Now I know it says normal acceptable all the way along this range here, but if you're way down here and it takes a 2.0 shim, 2.0 is the smallest shim that you can get. You can't put any smaller shim in. So if it's down here, you've got no room to go. So if you have wear of the valve face and you have wear of the valve seat over time, that's going to push the tip of the valve or the top of the valve further up toward the cam, pushing the bucket up and ergo requiring a smaller shim. And there is no smaller shim. Now when I talked to the engine builder, he had called me, told me it was done, and I was kind of in the middle of other stuff. I was actually out and about doing some errands. I didn't quite catch what he meant, but he said that we were at the end of the range as far as the installed valve clearance goes, and he said you probably would end up needing a 2.0 shim, and it just didn't register in my brain at that time what that ultimately meant. So I got the head in yesterday, as you saw, and let's go ahead and put number 3 exhaust valve in if I can find a stinking hole. First try. Look at that. Now what you do, again, I'm going to keep my finger on it to push it up to the face of the valve. What you do here is you take some sort of a measuring instrument. In this case, this Starrett 3202. I can get a pretty accurate measurement here. Yeah, that was about what I was getting yesterday, about 1.504, 1.505. So you got, it's unfortunately, you just can't really get it too straight. I don't think it really needs to be that quite accurate. I mean, if you're 5 or 10 thou off and you're toward the middle of the range anyway, it's not a big deal. Trouble with this is 1.505, when you convert that over into metric, brings you down about here. And that here is 38.22. So essentially you'd be down in here, which is unacceptable. You'd be out of the normal acceptable range. If you were at like 1.50, you'd be around 38.0 something, but it'd be up in here. So either way, you're either here or here, where it requires a 2 millimeter shim. And that is unacceptable because it's going to be too tight. There's no room to go. The valves have been faced and they've been touched in the back and brought down to the maximum amount they can be brought down. Now you might say to yourself, why not just grind some more off the tip of the valve, the top of the valve rather, and be done with it. But you can't do that because there's also a standard on the distance between the top of the groove for the keeper and the end here, and it's 160. I looked it up yesterday. In Imperial it's like 165 and we're like 172 right now, 173. We don't have enough room to go, and the problem with that is if you don't have long enough or bigger space here, this doesn't protrude high enough above the keepers, and when the bucket pushes on it, you can actually dislodge the keepers, and then the valve falls in the engine, and then you have a really bad day at that point. Yeah, so we are going to replace the valves. I've already ordered 8 brand new valves for this. The only thing we have to do is, because he sized the clearance inside these valve guides to these valves, we got to mic up these valves and mic up the new valves. And I called him yesterday. He said if it's any more than a couple of tenths bigger, you're going to have to do something in here as far as clearance, like maybe run a hone into it or something. I'll deal with that at that time. But either way, you know, we're going to make sure the clearance is right between the valve stem and the guide, and we're going to make sure our installed valve height is right. So really all we're going to have to do, because the new valves are going to come already ground with the 45 degrees on here. Let me spin the head over and show you that side. Haven't done that yet. Here's our number 3 exhaust that we were playing with just now. So all we're going to really have to do on all these valves, since he cut the seats, you have to do that when you put new guides in anyway, because it's never going to come up concentric again. You have to recut them. He just touched the seats enough to clear off the 45 degree angle, because you got the 60 to 45 and the 30. And so he did the, you know, the 45 is the contact angle, you know, matches the valve at 45. So he just touched these to clean them up and to get these valves to seat properly and with the proper valve guide to valve stem clearance, which feels really good. And you can tell these are good because you can't spin them. After I lap them, because all we're going to have to do is lap these, the new valves. We're going to have to lap them in. I'm confident we're going to have really good contact on each one because he's cut these. So really at that point, once we lap them and clean them so we have an accurate seating, we'll remeasure the installed valve height. Worst case scenario, if it's still a little too high, because this now is at full height, and I'll show you the two of them when we come in, it's going to be substantially bigger because these have been cut probably before. So that's where we're at on this. Unfortunately, we just can't put the head on yet, but we are going to soon once we get some new valves installed and everything jives as far as all the numbers go. All right, folks, a couple of days later for me, mere seconds for you, as I said. And today is Sunday. Normally I don't do this on a Sunday, but for you I make an exception. Ichabod and I are going to take off a little later and go to a car show locally. But I got a little time before now and then, so I figured I'd go over this with you really quick. But I want to show you the comparison here. So the installed valve height on the old number 3 exhaust, and they're pretty much all the same, is about 510 thou. Now if we take a new exhaust valve, we open her up, and we shove her in. We're going to measure the stems up here in a minute. You recall from the earlier parts of this video, I mentioned that is a critical component, if you will, or part of this equation. We have to have really no changes, or maybe a little bit smaller on the new ones, as opposed to the old ones, or we'll have some possible seizure issues in these guides. Like I said, we'll measure, get in the hole, damn it. We'll measure that up a little later. So roughly the same. 515 on one approximately and 515 on the other. So you're like, well, how is that going to help? Number one, you can see the difference in the margin. The margin is that edge. That is the kind of the flat side on it, if you will, between the cut, the 45 degree cut, and the top of the valve, the face of the valve. The margin on this one is pretty much eliminated because it's been cut, the valve's been cut back too far. But the margin on this one's brand new with a 45 degree right there. And you can also see the width of the 45. See how that's so much thinner than this fat guy on the right here? So that gives us more meat here, which pushes us down a little bit further into that spot. But we still have the stick out up here, which is pretty much the same as the old one. But remember, the old one, this has been ground back to the maximum amount. And you can see the difference here between the ends. You get an idea that it's been cut back quite a bit. You know, it's hard to see visually, but if we measure it, this is the old one. Yeah, about 170 thou, something like that. Yeah, about 170. Well, 165 is a minimum. Now, if we measure this guy here, go about 200 thou. It's about 200. 30 thou more. So this is 30 thou thicker to the tip than this one is. So remember, we're about at the same place right now with a new valve as we were in the old valve in regards to install valve height. But now we've got room to come down on the top here. We'll take a look at that again in here on this picture. You cannot go below 4.2 mil or 165 thou for your final dimension, which is the dimension A, from the top of the keeper groove to the tip of the valve. It says do not grind off more than 0.3 millimeter, but it's pointing at the chamfer here. So I think they mean the chamfer, because that's 11 thou. We need to take more than that off, so we're not going to worry about that. I think that's what they mean here, because I don't know why it would be do not cut more than 0.3 millimeters off, and they're only pointing to the chamfer. I don't really know what that means. So 165 is our basement, which is approximately 5 thou smaller than where these guys are, the old ones. So we take a new one. We got 30 thou to work with. I tried up here, which is 1.477, which would be about a 2.45 shim, and it would be a little bit more cut off here than I want. So we're going to be in this range here, 37.72 to 76, or 37.67 to 71, something like that, which is about 1.485 to, I don't know, 1.480, something like that. So what we got to do is essentially kind of prove that out by putting this in here again. So we're at 515 thou. Let's say we need to go to 485. All right, so there's 515. We're going to go to 485. That'd be 10, 20. It'd be 30 right there. So we would be right at the maximum that we can take off. So we may not even be able to do that one. We may have to go a little bit lower as far as the numbers go, because we still got to lap these in. It's going to push them up a little bit more. Yeah, about 510, let's say. So if we got 30 thou to work with, and we're at like 515, we go to 485, we've blown out any comfort zone there. We don't have any extra space left. We may have to move down here a little bit, but at least we have some room. I mean, it's the only thing we can do. The correct way to deal with this, send it back out and have the seats redone and put new valves in. That's really the best way to do this. They've been cut too much, and the old valves, of course, are scrapped because they've been cut too much. But even with new valves, we can only take so much off the tip here. So we're going to have to come up with a number, installed valve height, you know, acceptable, that we got some room to move. I was hoping to keep it around here, but 1.485, I don't know if that's going to work. If we're at 1.515 on install valve height now, 10, 20, that's 30 thou, and that's going to be a lot. So if we take 30 thou off of this, I mean, we're going to be at right at 70, 0.170, barely acceptable. Might have to come close to that, though. I'd really like to keep it a little bit more than that. But our minimum, again, is 0.165. I mean, that is a really close thing. I really like to stay away from that. The only way to do that is to go down here. So if we went down to a little bit lower, like 37.82 to 86, let's see what that is in Imperial. It's about 1.480. So about 5 thou smaller than this one up here. So if we were going to go 1.480 and we are at 1.515, and then, you know, we basically just, I'm only showing you this way so you can visualize this, but obviously I can do the math, but it's a little bit better. All right, so if I used 37.8485 or something like that, I get 1.490, roughly just under 1.5. We are 1.515. I can do the math, but I just want to show you in visual terms here what we're dealing with. There's 515, which is where our current installed valve height is. So now again, we have to lap these. It's going to maybe move it a thou or two, but assuming, you know, we're still within pretty much good tolerance here, to go to 1.490, we go 10, 20. We're only going 25 thou, which is still a lot, but it would be at least in a somewhat comfortable range where we have a place to go. I'd really rather be way up here, but I don't think there's any way we can do this because, again, the valve seats are just, they're cut too much. You know, essentially, where do you stop? You know, let's try another spot over here. Where do you stop on an old cylinder head like this? You know, it shouldn't have happened in the first place. The damn engine builder shouldn't have blown the damn things out, but unfortunately he did. And so, you know, we're left to deal with the carnage. But it's hard to measure. I might have to make something, like a tool or something. Let's take a look at this is really important as well. Take a micrometer and take a look at the diameter of the shank, the valve stem. 274 on the nose, 274 and maybe a half a tenth, maybe a tenth. This mic doesn't read intense, but I can tell you what that is from reading a micrometer 40 years. That's the same. Within a tenth or two, we're going to run with it. We're not going to worry about doing anything with the bores of the valve guides. Yay. All right, so at least that's working out for us. So, okay, well, so again, the next step, we're going to lap, recheck the stick out, you know, for the installed valve height, because that's going to change it a little bit. Then calculate in how much you're going to have to cut off for each one. And then I'm going to have to bring them individually, or bring a lot of them down and do them individually. Can't get that out. And cut off a certain amount off the end, chamfer it a little bit, and that'll be the installed valve height at this location. They're all going to be pretty much very close, I think. Is taking off like, you know, 20, 15 thou, 20 thou. I would really not like to go any more than 20. I'm 10 thousandths above the minimum, which I'd really not like to go any lower than that. So I have to calculate that out at that time as to how, you know, if I take 20 thou off, am I going to be in this area where I'm still going to have a little comfort zone, and then pick out whatever shim's going to go in there. But we have to do them step by step, so that'll be coming up shortly. All right, so here's what I did. I need to make sure that I made a tool basically. I need to make sure that I know exactly what this installed valve height is. I can't trust this. It's too all over the place. It can vary up to even 10 thou or more. And since we're kind of threading a needle here as far as installed valve height, being that these seats are probably really on the borderline, but we're going to have to work with them. I made this. Now this has clearance on the bottom for the valve guide. Here's one of those valve guides I showed you earlier for an exhaust. From here up, this little edge is exactly the same, because that's where the seal goes. So I made it so we got plenty of clearance for that to sit in, because this little higher ridge here is what butts up against the aluminum inside there and sets the depth. So I needed to make sure we wouldn't be influenced by that. So that sits in like this. This is exactly 2 inches long, and it's got just enough clearance for the valve stem, so it's not going to be wobbling all over the place. And again, it's 2 inches exactly. So when you put it down inside here, and I have the valve clamped with just one of these plastic clamp deals, so I can use 2 hands. And now we can just make sure everything's clean and go in here and plunge down on top of the valve stem directly. Hold good, you know, good force on that tool so it sits flush, sits flat. So we take this dimension, which in this case is 499. I got 498 once or twice and 499, so we'll go with 499, and you subtract it from 2 inches. All right, so basically it's 1.5 inches. So essentially, you know, actually a little over 1.5 inches, but 1.501, 1.502. And that's a hell of a lot different than 1.515. So, or 1.510 I was getting. So since we're threading a needle, I absolutely need to know what these are. Because if we're at 1.501, we only need to go 11 thou to get down into here, 1.490 for an installed valve height. And if we go a little bit more, we can get up into here. So it all depends on your starting point. And I'm pretty sure this is the one I lapped already too. I just did some test lapping, and this is number 4 exhaust. So this is a really good, accurate way to do this. Yeah, 499. So 1.501 would be my installed valve height currently, which is way down in here again. But if we just knock 10, maybe even 15 thou off it, even though you're only supposed to take 11, but I don't understand this. That's what 0.03 millimeters is, or 0.3 rather, is, you know, I don't quite understand this, because it gives you a minimum after grinding of 4.2 millimeters, but and that's 165 thou, but you're starting at about 200 thou. So that's, you know, that's 35 thou. So where do they get that from? In other words, why would you only take 0.3 off when you can go all the way down to here and still be high enough where you're not going to knock the thing, you know, as far as hit the retainer and knock the keepers out? It says that, in fact, right here. If the valve's dimension A is less than the specified, the valve lifter may contact the spring retainer. That's the specified, the minimum specified, 165 thou. So again, I don't quite understand that. I'm going to have to assume that this is a misprint. This is, you know, stranger things have happened, and there's a lot of errors in these service manuals. I would say what we're going to end up doing here, let me go back to this page. Since we're at 1.501, it looks like, on a current installed valve height on this valve that I did lap, and it cleaned up real quick. I'll show it to you here in a second. Cleaned up real nice. Since we're at that, if I did 15th hour or so, I think we could be in this area. Because we'd be at 1.485, 1.486, and that would be, it would give us some room at least. I don't think we can go any more than that. I don't think I'd be comfortable doing any more. I was thinking 20 would have to be the number, but that's when I was measuring with this. So obviously I was getting an incorrect measurement. So now I can measure these exactly. Within a thou at least, I would say. We can make a more, you know, informed and accurate decision as to how much to take off the tip. And I think knowing this now, I'm pretty sure we're going to be able to work with this. It'll be the last hurrah for this head as far as the valve seats go. How much is he going to ride the thing? You know, over how many years is it going to? If he was putting, you know, 50,000 miles a year on it, I'd say we're going to have to change the seats out. But he's not going to be riding it that much. So if we're up in this area, we got plenty of room to go where it might tighten up over time. And then Bob's your uncle. It's about all we can do. So I think this was a great idea to do this personally, and it works really well. And if we go over number 3, same deal. I don't have a valve in that right now, but you see it fits in all of them. And then you just do your thing. I think that's a way to do it. There's no way to check the install valve height with the springs in, which is what you'd really like to do because it's pulling the tension on it. There's no room on the side of these springs, and plus you got a spring seat down inside there. It's going to skew the reading. So that's not going to work. So there you go. You got to do it this way. So now we know. Now we know we can go in at least some direction that's really close to what the service manual says, which again, I think is a mistake. I think this is an error, personally, but I don't know. That's just my guess. Because if they give you this as the minimum, this doesn't add up. Essentially, you would essentially start at plus 11th hour, 0.3 millimeters, and then that would bring you down to 4.2 millimeters. And this is 3 times, this thickness here right now is 3 times that. Almost forgot to show you this valve, how it lapped up. There's going to be no need to blue this one. That's perfect. Nice even line around it. Got good contact. It's basically where I'd like to see it. And so I'm real happy about that. So if all of them come up like this, then I think we're going to have no problem at least bringing it in. Unfortunately, be toward the tighter side, and you know, it's just one of these things. But as you know the story already, it's the best we can do. All right, folks, we're going to pick up after the last clips, which I shot months ago, or maybe weeks. I don't remember. My wife and I have been really sick over the last couple of weeks. I think she's got a touch of pneumonia. We've had multiple doctor visits and steroids, antibiotics. And I kind of forgot where I left off, so I reviewed those clips. And apparently we were up to the point where we were dealing with the installed valve height issues with the original valves. So I ended up picking up 8 new valves. And that's where we're going to pick it up from here. And we're going to take a look at the installed valve heights. And we're going to do something a little bit different that I just recently learned about from Jay at APE, American Performance Engineering, I believe that is. They deal with a lot of KZ1000 Kawasaki performance engine builds, like racing engines. And so I had 2 different conversations with him. And I picked up I'll show you. I picked up some parts that I know are going to help us out here, but it's going to be a little radical. All right, this is number 2 intake valve, or it will be number 2 intake valve. I've already done number 1, which is right here, and this is number 2. Now I'm going to show you what I do to start off with is lap these. Because number 1, we want to make sure that it's got good contact between the seat and the face. And number 2, we just want to make sure that it's going to seal, and the lapping will tell us that. So we're looking for a nice even line with no thin and thick parts, and at the appropriate level, or at least close as possible, up the face as far as from the base of the valve up to the top. And the margin's in good shape because these are brand new valves, all right? So we have a good margin, and these have not been tipped yet. We're going to be tipping in them all, a couple of them very significantly, which this is one of them. So anyway, this is what we're going to do first, is flip it over. We'll put a little oil on the stem, help us out. Why not? Protect the stem a little bit. Oh, I should say the guide too. And we're going to put some valve lapping compound. This is fine compound. I believe it's Clover brand. It's a good brand. Fine lapping compound. Don't want to get any on the stem because we don't want to drag that into the guide. So I'm very careful about this. Naturally, this whole head is going to get very thoroughly washed and cleaned before it gets reinstalled, everything reinstalled. But suction does not want to suck today. All right, that should be good enough anyway. You can see that that looks pretty damn good. You got a nice even line around the entire circumference, right exactly where we want it basically. It's going to be what it is for us as long as it's not real wacko. That actually looks pretty damn good. So these have been cut, of course, at the machine shop up in New Hampshire, and they're cut too deep. That's the whole problem. But he didn't have a choice. But I'm confident now that this intake valve is going to seal real well. Now we're going to test this once the head goes back together. And how I test it is I put the spark plugs back in and I have the head upside down like this. And I fill each combustion chamber up with gas and just let it sit for a while because gas will find its way anywhere. And if it starts dripping down the exhaust, the intake or the exhaust ports, then I know that that's got to come apart and be redone. I don't believe that that's going to be the case on this at all. The way this thing looks, it looks like it's going to be perfect. I tapered it like a 2-degree taper inwards on the lathe. You can just kind of see that little edge right there. About right from, let's see, if I can show you right here. If you go right from about here to there is untouched. And it's exactly 2 inches. So that's 2 inches. So now that that's in, it's good and seated real well. See, I put that little chamfer, little degreed in there because I noticed it was rocking a little bit, probably because the aluminum gets a little distorted around the area that the valve guide is pushed into. And so I didn't want it to be so tight up against that guide, it might be a little bit off. So right now it's sitting on the outer edge of that flat area. And I think we're getting the most accurate reading that way. So now what we're going to do is just simply make sure that this valve is seated all the way, which it is. And our reading is 470 thou is our reading. Remember, a depth mic reads this way, not that way. So this would be 475, and we're at 470. Now what I have here is a chart that I made where I'm documenting all this so I can do calculations and also document it for the future. So intake number 2 is 470, 470. I just write it over there. So 470 is our depth, and so we simply subtract that from, well actually that's right, yeah. 470 minus 2 inches is 1.530. I obviously checked this one before, I forgot that I did that. But I wanted to show you guys anyway how I do it. So again, 470 minus 2.0 is 1.530. So that is where we're at. Where we want to be is 1.480. Now where I get that from is from the factory service information, and also I talked to Jay at APE, he said 1.480. Imperial is where they'd like to target as well, which I think is around 37.57, so it's right in the middle of the range here. The difference between 1.50 though, I'm sorry, 1.480 and 1.530 is huge. That's 50 thou. So 30 thou to get you to 1.5 and 20 more to get you to 1.480. So that's 50 thou. According to the factory manual information, the maximum you can take off is 0.3 mil, which is 11 thou. But we have to take off 50 thou to bring it in. So how do we do that? All right, so this part I'm going to show you is a little technical and maybe even hard to show on video, but we're going to do it anyway. And what we have here is 2 things. A stock valve keeper that came out of my kit. Sorry about my thumb here, but I cut the crap out of my thumb the other day. Let's go ahead and take that off because it looks really bad. It's better than it was. Let's get that out of the picture here. All right, so again, this is a stock valve keeper. I'm going to zoom you up a little bit. Really a spring keeper, but you know what I mean. Now when you put that one up to the top here, quite a bit of, or it's really close to the top. In other words, it sticks up very high. So there you go. This is where it sticks up to. What I got from ARP is shortened keepers. They're designed for this exact purpose. And with that one pushed all the way up against it, because of course there's a little bit of play in these, so you have to mimic the fact that the spring's going to be pushing upwards. With it pushed all the way up, you see the difference. Let's put them both in there and so you can see it vividly, the difference. Okay, so they're both pushed up. You can see that The one on the right is really close, and the one on the left has a great deal more space because that's the lowered one or the shortened one. So what I did was I measured these, but I measured the depth of this one. This is the lowered or the shortened valve spring keeper at 94 thou. So from here to the top of that, with it pushed all the way up like that, is 94 thou. And when I measured the stock one, with it pushed all the way up, it was 34 thou. All right, so that gives you like, what is that? My math skills ain't too good today. Of course, they're not good any day. It gives you 60 thou. So there's basically a 1/16 of an inch difference between those two. And let's say we wanted to try to maintain that 34 thou stick out. This is an unmolested valve stem, all right, or valve tip. And if you measure that, it's about 34 thou. Let's say we wanted to keep that. You know, in my opinion, we want to be as high off the retainer as possible. Bring this up 34. So this is for an uncut one. There are some that I have from the machine shop that are cut. They're about 44, 45. I want to compare apples to apples because these ones that are shortened have not been cut. They're just designed shorter. So we got, again, about 34, maybe 34.5 thou, where it starts to kind of rub across. I can feel it rub across that the top of that keeper. We're going to go with 30, 34. And again, the one on the shortened is 94. Yeah, I just checked one of the intakes from another bag, and that one is cut, and it's around 44. So that would be an invalid measurement because I want to go off of unmolested. So again, this is 94. I can just feel it rubbing across there. And this is the shorter one. 34 to 94, like I said, 60 thou. So if we're going to try to maintain that 34 thou stick out on the top here, which would be nice to do because that's essentially what it would be like if this valve fit unmolestedly, or, you know, without any changes, grinding or anything. What would we have to take off to get to that point, and would that jive up at 1.480? So what we have to do is, since it's at 1.530, we want 1.480. We need to take 50 thou off. The difference between 50 and 94 is 44 thou. So we'd actually be bigger than the 34 that we're kind of trying to achieve. And that's kind of a personal thing. I don't know if that's right or not, because when I talked to Jay at APE, he said it doesn't matter how tight it is to the top of the keeper as long as it's proud of it. So the top of that little button in the bucket sits down on this and doesn't touch the keepers. He said they built engines. I don't know how true this is, but they built engines that were like 5 or 10 thou proud, and they were just fine. They do it all the time. So again, if we take 50 thou off of this thing, and we've got a 94 thou clearance, that's 44 thou. So it'll work. It'll work with these shortened keepers, which is, he said, I called him 2 times, the second time to clarify things. He said, look, this is what these are made for. They're made for when the seats are too deep, all right? They're made for when the seats are too deep, and you don't want to, or you can't put seats in for some reason, either cost prohibition or other reasons. All you got to do is knock these valves down, and then these things will line up properly with the correct installed valve height, and there'll be plenty of clearance between the top of the keeper and the tip of the valve. So that's exactly what we're doing, and what I have done so far. Let me not mix these guys up. I got to put that back in the bag. I can't lose any of these. They're not terribly expensive either. Now, when you do this in concert with the lowered keepers, he wants you to put 30 thou shims, excuse me, underneath the spring seats, which I did buy as well. So there's basically washers, and they go down underneath the spring seat. He said because what's ended up happening is because these are sucked up further into the head because the seat's being cut so far, essentially you're not changing the groove, you're only changing the tip of the valve. So the distance between where this thing sticks up through as far as the groove goes is actually higher, even though we're compensating for it by cutting the tip of the valve. Ergo, the spring pressure is a little bit less because it would be more if it was pulled down that way. There'd be more tension on it. So he said what you want to do is you want to put a shim underneath there. That compensates for it and also really helps to keep those keepers in, especially high RPM. He said we do it all the time. He said we build engines this way all the time. So that's the plan. As far as cutting the valves go, I have a way to do it, but I'm going to discuss that in a little while. So let's go ahead and take a look at number 1, which has already been done, and I'll show you the difference. This is intake valve number 1. You can see it's already been lapped. I'm doing that before I do any measurement. This one looks just as nice. I wouldn't expect it to be otherwise because, you know, we used like a sunning machine to cut the seats concentric with the guides. So that looks really well, you know, just like number 2 and one I just showed you. This is the tip of it that I cut in-house. So this is done, and you can see it looks really nice. And, you know, one thing I don't know is, and I know if you take a brand new valve and you try to run a file across it, it's definitely hard on the tip. But he told me, he says, you can cut these down, these stock. He didn't say they were stainless. You know, I told him we had brand new aftermarket, but OEM quality, you know, valves for this thing. And he says, just cut them what you need.
Just cut them, dang it.
Okay, well, maybe Jay didn't exactly say that on camera, but you get the point. I don't know what these are made of. I don't know what the tempering or the heat treating or any hardening on the tip goes. And maybe that's why Kawasaki says to only take 11 thou off, but I can't see that any heat treating or hardening on the tip of this would be more than 11 thou. I think it might be a coating that they put on them, and it just coats the whole thing because obviously this has been ground. This is not hard. This is an intake valve. It's a little different material than the exhaust valve as far as I understand. Still, you're going to want to mix, well, I can't mix them up. This one's cut. But, you know, the thing is, as far as the tip goes, I really don't know if that makes any difference. He said to cut them. He said, like I said, we build engines like this all the time. They use both stainless and regular valves like this, whatever these are made of. I don't know. So I'm doing what the guy said. They build race engines, so that's what I'm doing. So this one was cut 39 thou exactly. And when I did the measurement, let's go ahead and put it in number 1 where it goes. All right, so now we're in number 1 spot with the number 1 valve. Let's go ahead and take my stupid clamping mechanism here, wherever I put it. There it is. All right, I got number 1 clamped in. We'll put our tool back in. Make sure it's sitting nice and flat. Valve is up against the face. We'll go ahead and remeasure, show you what I got. And you want to stay as centered on this as possible. Get the most accurate reading. Because there's a little chamfer on that valve on the tip. Okay, and the reading that I have now is, let's see, it's 519. So 519 thou. Do the sound calculation. 2 inches minus 0.519, which is 1.481. I think when I measured it yesterday, I got 520, not 519, but that's close enough. Yeah, I'm closer to 20 now. So essentially 1.480, 1.481. And that's what we're looking for. We're looking for 1.480. And if you take number 1 valve out and we put the lowered keeper on, the shortened keeper, I should say, show you what that looks like and how much stick out we got. And remember, this was a 39,000th cut. So number 2 requires 50 thou. So that's, you know, a significant amount more. We got to drop 11 thou more off of that thing. And there is our stick up from the shortened keepers. And if we measure that just for shits and giggles, I could have done the math on this, but this one is 55, 56. Yeah, about 56 thou is the stick out of the valve tip from the keeper. I see that right there. So that's quite a bit of stick out. Now, of course, that's going to vary because the more we take off the tip, that distance is going to get smaller. I just don't want it smaller than around 34 thou. That's just my personal choice in this matter. And based on the math, number 2 and number 4 intakes over here are the worst. I've already checked the exhausts. The exhaust is not bad. Exhaust won't need much at all, but I'm going to recheck those off camera. This is going to be just fine. Now, as far as cutting these, you're supposed to grind these, but I'm not really sure why. So what I did on this, well, let me just go ahead and show you. I'm not sure why you'd want to do this with a grinder. That's a lot of material to take off with a valve stem grinder, and I think you'd generate a significant amount of heat on the tip of that valve doing it without some sort of coolant. But I found through experimentation, and what I did was I have some old valves laying around, and the ones that came back from the machine shop from this one, and I just put them in the lathe here and started playing, and I can tip these valves very easily with carbide and take off exactly what I need and use the DRO, and then I know exactly where I'm at. So this is number 2 intake. like I said, this is number 2 intake. So we're gonna do that, this one, I'll show you what I mean. And I have set this tool height up through experimentation on other things, like other valves. It is exactly in the center. So it's not gonna leave any nipple or anything like that, or any dimple. That's the wrong one. I'm gonna make sure that that insert is nice and tight. What you can do is just, like I said, you can use a DRO and then dial in exactly what you need in increments. So we need to take 50 thou off this valve. Now I know the valve length already, and what I'm going to do to verify this is I'm simply going to subtract 50 from the valve length and then measure it. And when I'm there, I'm good. So what we're going to do here is we're going to touch off. I got the DRO on, turned on. Then we're going to set 0 on the Z-axis. And then we're going to move it in 10 thou increments. And we're going to use the powered cross slide. That way we get a nice even finish. So that's how I did it yesterday. It worked pretty well, and that's how my test went as well. I'm going to run maximum speed at 1400 RPM. So that's A2. Get a good surface finish. All right. We'll lock the carriage each time so it doesn't move. I got the carriage lock ready to go here. And all we got to do is touch off, and then we can take it from there. This is how I'm doing it. And afterwards, I'm going to stone it. We're going to stone the end. We're going to polish it with some emery. And then the reason why I have the cutter turned this way in the tool post is we'll move it over and we'll run the lathe in reverse and we'll do that little chamfer on it. All right, just touched off. Go ahead and 0 the Z. Yeah, I got a nice slow feed. I'm going to take it real easy. Dial in 10 thou. 10 thou. Lock the carriage. Engage. You run a super slow feed. And that surface finish is like a mirror finish. Looks beautiful. There's 20 thou. I'm going to speed up the feed on the roughing passes a little bit. There's 30 thou. Carriage is locked. $40 thou. I'm going to go to 48 because my experience, it wants to cut a little bit more off. I'm going to slow the feed back down. We're going to go to 48 thou. The finished length, this is 3.600 even. Ouch. Got my finger in there. 3.600 even, so we want 3.550 when we're done. So the feed slowed down. I'm going to go to 8 thou instead of 10. And I'm telling you, that surface finish is like a mirror. It looks so nice. This is an aluminum insert too. Sometimes these work really well for kind of exotic materials. All right, let's take it out and measure it up. Okay, this has been finished up with a little chamfer, which kind of matches up with the factory one. There's your surface finish. I mean, this thing, I don't understand why people don't do this because you're taking that much material off. I mean, you might as well just cut it like this. It doesn't generate any heat into it, and it's smooth. Really smooth. I cleaned it up with some emery as well, polished it up. And as far as the length goes, I mean, this is the way we're going to do it, period. I mean, maybe wrong. Somebody might turn around and go, oh my God, if you cut that, it's going to crash and explode. But so we're at like 150, I'm sorry, 1.551, 52. We're within 2 thou, close enough. I'm not going to put it back in for freaking 2 thou. So 52, close enough. So let's put it back in the head in that spot for number 2, and then we'll measure it. We'll have to put it in a baggie like the other one and mark it. I'm also going to mark the install valve height on the bag. 527 and a half. So we'll go with 528. Well, my math must have been a little off on this one. I don't understand how, because I measured it at 530 thou. 1.530 rather is the installed valve height. 1.48 is 50 thou difference. Took 50 thou off. It's a little deeper. I don't know what the hell happened. I must have mismeasured it. Not scrap. Not any means anywhere close. But it's 527. You'd subtract 527 from 1.250. It's I'm sorry, 2.0 rather. Where my brain is. So 527 minus 2.0. 1.473. So it's 8 thou away from 1.480 to the larger side. That's okay. It's not going to be a problem. You'll just take a slightly larger shim. The main concern, of course, because we took so much off, is to check the stick out of these shorter, what do you call them? I just had a coughing spell, so my brain is not 100% here, sorry. What is the stick out? She's got some distance to her. Let's measure it and see what it is. Maybe 37. So we're really where we want to be anyway, because 34 for a stock one, unmolested with a regular unmolested keeper. Now we're 37. So this is the critical part, is do we have enough stick out on the top of the keeper to make sure that the bucket doesn't disengage and ruin the engine? And the answer is obviously yes. We got 37 thou there. And this is, again, pushed up against it. So this is a really great idea. I'm glad I called ARP for that. So that's essentially what I'm doing with this. I know it's kind of a long explanation. This is going to be a long video, but some of you guys like the long ones. I don't know. I like it long too, but that doesn't happen anymore at my age. What we're going to do is do all the rest of them off camera. I'm going to remeasure the exhaust, do a better job in figuring out where I must have measured 7 thou off of something, but doesn't matter. As long as our stick out is good enough on this, I have to assign this one to a baggie for number 2 intake, and label it as 1.473 for a installed valve height, and that way we can calculate the shim at that time that we would at least try first. Because what we're going to do is we're going to build this head after it's all cleaned up thoroughly. Then, and I'm going to put the cams on the bench and do one side at a time, do the intake and exhaust separately. And you can just rotate the cams around. Once we get that done, we're all set. I'll just leave the shims in those buckets installed in the head, put the head on the bike, then put the cams in, and Bob's your uncle. So that's the goal as far as what's happening. So let me go assign this to a baggie. The next clips you're going to see, this will be all done. Of course, the saga continues. What I mean by that, saga continues, is we had to make some more modifications, do some tomfoolery to the cylinder head, but it's mostly done. Let me go over what I did here. You already saw the clips where I bastardized the valve stems by shortening them up and bringing them all to a certain length, certain install valve height, which in this case we're looking for about 1.480. So we're basically in that range here, okay? 1.474 is the smallest one. Cut a little bit more off that one by accident. As for intake number 1, down to 1.481, which is the tallest. So it's really within a good range here, you know, 6-7 thousandths or so. All that's going to mean is a different size shim. Speaking of shims, I have the shims in. These are mostly the original ones that were in here, because when I took a look at the sizes in millimeters, they looked about right where the installed valve height should be about for this. Or I should say the shims for that particular installed valve height. 1.480, it should be around about 2.40 for a shim, because that's the 1.480 metric equivalent right here. So about 2.40, so they're between 2.40 and 2.45 right now. I have them all written down in imperial on the back of this page here, because I always do valve clearances in imperial because my tools are imperial. It's just easier for me to figure it out. But anyway, so let me move on from there. So let me show you what we ended up doing. I don't know if this is right or not, but it's the only thing we could do. So this is intake number 2. Most of the intakes are this way. Actually, all of them I think are cut. So what happened was, when you cut the valve stem down and you use those lowered keepers, in other words, the shorter keepers, that works great as far as the distance between the end of the stem and the keeper itself, which is really, you know, an important measurement to consider. What I didn't consider at that time when I did this was the distance between the stem and the retainer. So I started putting these in with intake number 1. I think that's the same way as well. Yeah, so intake number 1's the same way. But when I did intake number 1, I looked at that and I noticed that this valve stem was actually at or below the level of the keeper. And I said, that's not necessarily a good thing. Now, there is a little button on the inside of these buckets that pushes down directly on top of the valve stem right there, all right? Now, the trouble with that is, though, the bucket, the button rather, when I measure it from, depth-wise, is about 15 thou. If this is at the, let's say it's at the surface, exactly at the surface, that only gives you 15 thousandths of clearance before this could potentially bottom on there. And, that's not necessarily a machine surface, so what are the irregularities and stuff in there? So what I ended up doing was I ended up calculating I needed to take anywhere between 10, 15, 18 thousandths off of these retainers. So I figured out a way to fixture them, and I didn't do all of them, just the ones I needed. Fixture them in the lathe, in the 3-jaw chuck, and just use carbide and face them, and they came out real well. They faced great. There was no problem with that. So what I ended up doing is I brought these, so the valve stem is at least 10 thousandths proud of the retainer. So it's 10 thou there, 15 thousandths here, that's 25. There's no way that that's going to hit that. So not all of them are like this, as I said. Not all of them are like this. Not all of them needed it. For example, if I go over here to an exhaust, I believe, so you can see the difference on these two here. So this one's was cut and this one's not. This one's quite a bit more proud, of course, than the ones that are cut. But they're very similar because I had to cut these stems so much. So this one's probably about 20 thou proud. Let's say they're a minimum of 15, 10, 15. I'd say 15 over the retainer. We're going to have no problem with the fact that this button on the inside is the only thing that's going to contact the valve. Because if it's pushing on that retainer, then good night Irene. Because what happens at that point is it disengages the retainer. The retainer, and then the keeper's dislodged. Because the retainer is pushing down instead of just the stem on the keepers, which is translating that force the way it's supposed to work, and you drop a valve into the motor. I talked to the customer about this, and I said I wasn't terribly comfortable doing it, but it was the only option we had, and he said, go do it. We'll take the chance. He says, I understand the risks, and so that's what we're doing. Besides these, these shortened retainers, these keepers rather, I installed these shims. They're 30 thou shims that APE recommended I install. They go underneath the spring seat, and then the spring seat goes down, and then of course the spring, and then the keeper and the retainer and so forth. So that's all done, keeps additional pressure. I'm not 100% sure. I tried to explain it before, but I'm a little bit confused on why that's necessary. But they said to use them, they build race engines, so that's what I did. So that's done. The last thing I did was, I did turn this thing over and tested the integrity of the valve sealing. And how I did that in this particular case was, put the spark plugs in, turn it over. Normally I use gas, but this time I used alcohol because it's pretty thin. Fill up each chamber, combustion chamber, with alcohol. Let it sit for a while. Then you just look in through the ports to see if there's any leakage, which there was not. I didn't think there would be, because as you recall from earlier clips, we had some really good contact on the valve seats. So what we're going to do now that you've been caught up to date on this is, I'm sure the engine builders out there watching this video are screaming about right now, going, it ain't going to work, it ain't going to work, and who knows, maybe it will, maybe it won't. But I told a customer, I'm not an engine builder. I don't profess to be an engine builder. I don't want to be an engine builder. All I do is fix them. Normally fixing revolves minimal work as far as like cleaning up valve seats with the knee-way kit, maybe grinding some valve faces, putting them back in. This was extreme because of the extreme circumstances. Extreme circumstances require extreme solutions sometimes. I think that pretty much qualifies as an extreme solution on this. There isn't a whole lot I took off of those retainers. I mean, they're pretty thick. They are hardened, but not that hard. Like I said, carbide, no problem. I could face them easily. So that worked out real well as far as that goes. So I'm pretty sure it'll hold together, but, I'm not 100% sure because, it's not as designed, if you will, engineer-wise. But then again, what is, right? So the way the math works out right now, there is no inside of a bucket hitting a retainer. It's only that button on the bucket that is hitting the end of the valve, and the keepers are well below that. So there should not be any disengagement of anything. Otherwise, we're going to have a bad day, and I don't like bad days. So let's go down to the next step here, where I'm going to get the cams. I'm going to start doing valve clearance right here on the bench. I'll show you how I do that real quick. Load the bearings up, load one cam up, and then tighten the caps down. And then I'll show you how I do that on one or two valves. I already know what the thickness of these shims are because I wrote it down. I measured them, as I said before, in imperial. So I took a guess what these would be, a mixture of the originals and some ones I changed out. And if I think I'm right. So we should be pretty close. So let's get to it and see if I am. First thing I do is I take 2 pieces of wood, one on one end, one on the other, so it's just underneath, or just inside, underneath that hole where that M6 goes. We're just gonna cinch that down like that and do the other side as well. That raises this thing off the deck, because when I have the cams in, it's gonna push the valves downwards, and I don't want them smashing against the bench. So that just gives me clearance to do that. All right, and it looks like this. When you get it to that point, you just have, you know, a couple of blocks of wood. And you got plenty of room, like I said, on each side for the valves to move. That's the whole point. You want the valves to be able to move. I see some of these threads look like they have helicoils in them. So that's not a good sign. But I'm going to torque them up to spec so I can get an accurate measurement here. And it's 95 to 113 inch-pound. Yeah, foot-pounds. So we'll just see what we can do with that. I got it set at 100 inch-pounds. I mean, it looks that way. I mean, I could be wrong, but it looks like you can see the top edge of a thread insert. And I did, of course, lube the bearings, cleaned them off really well, lubed them with both. I use a combination of this assembly lube and motor oil. In fact, when I do that on the valves, I use definitely a combination of that. I don't just use assembly lubes on the valve stems when they go into the guides. I just don't like doing that because it's awfully thick. So I use a combination. So I guess that doesn't matter at this point, but intake valve, it's in correctly because the marks are on this side. This side is the left side, which you normally see that back side of the cam. Then it's just a matter of turning it to wherever you need it to be. Over here, right there. So right now we're at number 1, pretty much where it would be set at top dead center for number 1. And, you know, you have the lobe facing that way. The exhaust lobe would be facing that way if there was a chain connected to it. As long as you're on the base circle, it's fine. So now we're going to just go through each one. And I'm going to do only like 1 or 2 on camera, but we go through each one by rotating it around. And I can measure it right here on the bench. And I can even adjust it and put the proper shim in it too. So the spec is 2 to 4 thou. This is a 3. That's a country mile. I thought that it might worked out that way. Let's go with a 6. That's a country mile. I think we got to go with a bigger shim, don't you? Because the manual even says the estimated shim is like, you know, 2.40 to 2.95. So it all depends on, you know, what you got going on. Right now, that is 1/8 thou, and it's too big. So we're going to definitely have to come up on a shim, but I want to know how much. All right, folks, fast forward a couple days, and last clips you saw, I was checking the clearance on the intake side. Country mile is probably a little over-exaggeration. The shims I ended up putting in were certainly bigger than what we started with when the engine builder did this head, but that, you know, makes sense considering all the seat cutting had to be done at the machine shop we sent it to, and then all the modifications I had to do here. So I was getting a reliable 1.480 or very close to it, which should be putting me in the 2.40 to 2.85 range. And I'm at the top of that range on the intake. The intakes are 2.85 and 2.70 respectively, 1, 2, 3, 4. The exhaust turned out to be 2.60, 70, and 75. So it's within what they say here. What this says is you start with this shim, if this is the installed valve height, and expect it to be within this range, which in this case would be 2.40 to 2.85. So we're basically there. I wish it was a little smaller, but again, I was going off the numbers in this. So it's one of these things where you really don't know until you do it. But it's kind of nothing you can sneak up on. I mean, you can't just cut a certain amount off the valve and then put it in and install it and try it. Well, I guess you could, but that would involve a lot of cam removal and installation to do that, and then check clearances and stuff to dial those in. So I think that's why you go off of the installed valve heights. These heads are notorious for stripping out threads here, and I've already repaired 2 of them. This one here and this one here. The majority of all of them, the rest of them rather, if not all of them, are already thread repaired. I can see it, and some of them don't even look that good. I was able to get it torqued up. I'm only going with 85 inch-pounds. The manual says 95 to 113 or 115, and I tried 100 inch-pounds, and that's when this one stripped out. And but then I looked in there and said, well, that hole didn't look that good anyway. So I ended up repairing these over on the mill, just putting it on the table, lining it up, and doing my normal thing. And I did this one this morning because this one stripped out when I was doing the exhaust side. So, you know, these things are just a pain in the ass. They're only getting 85 inch-pounds, and that's it. I read a comment somewhere, somebody put a comment on one of my videos that that's wrong in the specs anyway, but didn't say what the proper spec was. So I'm doing 85, and it seems to be tight enough. And over here we've got everything laid out. So I have between 4 and 5 thousandths clearance. I know the spec is 2 to 4, but I want to go on the larger side on kind of a fresh top end because typically they tighten up pretty quick. So I got 4 to 5 thou. There's like one that's 4. I think number 4 exhaust is 4 thou, and then the rest are all about 5. So that is where it's going to stay. I don't have 1/4 millimeter size shims in this kit anyway. If I had 1/4 size, I could probably dial that in a little bit better, but it's close enough. And then the rest of it just has to be put back together, like these studs. And then we'll slam the head back on, but it won't be today because we got some other things to do. So in the next couple of days, we'll fire it back up, get this put back on, and get the timing chain routed up and cams in, yada yada, and hopefully we don't strip out another one of these, which is another reason why I really like to do it over here on the bench. Because if you're going to strip out a bolt, an M6 bolt on one of these caps, you want to do it with the head off the motor. It's a real pain in the ass to fix these on the motor. I've done it before on a KZ1000 years ago with a J motor, and it was not easy in situ. So, all right, so that's where we're at, and I'm going to go clean up the mill and clean up my mess, and then we'll get back to it in the next couple of days, hopefully. Well, the time has now come. We're going to go ahead and just get it back together and see how we screwed up. That was relatively painless. The buckets are in and the shims, everything's torqued down, and I retorqued as what you saw in time lapse. And so I want to put the cams in, but off camera, because most likely if we strip something out, there's going to be high velocity tool launches and a lot of potty mouths, so you don't want to hear that or see that on video. So we'll come back when the cams are in, just before we put the tensioner in. All right, I skipped ahead, sorry. Got the cam chain tensioner in. I'm just going to go ahead and bar the motor over and get you in a better spot here. Just see my fat arm. I already rolled it around once. What I'm doing is I'm doing a classic reach around in here and kind of snugging this tensioner up by hand and rechecking my timing marks, which I already did. Because this is not traditional like the regular one where you do a timing mark on the exhaust side and then count a certain number of links. It has 2 individual timing marks that line up with the top of the surface of the head. All right, let's double, triple check our timing marks. I'm going off the instructions. The engine builder actually provides a nice detailed instruction sheet on the manual cam chain tensioner, so that's all I'm going off of. It was in the packet of information the customer provided me. It's one good thing about this guy. He's pretty thorough about his documentation. There's number 1. There's the intake. And then the exhaust over here. All right, this is what we're going to do now is... I'm not sure about the battery status, but I want to run a compression test on it now that I've got this set up and spin it around with the starter. Again, run a compression test, but the battery may be smoked, so we may have to just take it out and put it on charge and use the jumper pack. And once it goes around a few times, we'll finish adjusting this tensioner. Okay, battery's got plenty of balls, so we'll try that. I want to recheck the valve clearance after I spin it around a little bit. I'm not running it right now for a couple of reasons. It's not important, but right now we're just going to run a compression test on it. See, it's a good time to do it because it's got open intake, so I'm just going to do it now. It's when I typically do it. So this is number 4 since I'm on this side. Contact. Yeah, about 170 right now because there's oil in there. You see the oil puffing out from when I, installation? That got good compression. Even more now. Cool. That'll all burn off, no big deal. Okay, number 3. Close to the same. That's because there's oil in there, like I said, from assembly. Because before I put the head on, I did put a little bit more oil around in the cylinders. So basically the same between 3 and 4. That's good. 4 and 3 in this case. Number 2. 175 or 170. I was bouncing up on 175. Here's number 1. Battery's starting to get tanked. Yeah, about 175 as well. So the original engine builder specs have 175 to 180 on all 4 cylinders. Actually 180 on like 1, 2, and 4, and then 175 on number 3. But we're running out of battery here, so I'm going to call that pretty much the same. I can tell you right now, them valves are sealing just like we tested it as such, so that's good. It sounds all right when it cranks, except for the battery getting low, so I got to put that on charge. So I'm going to go ahead and readjust this. See, all I really do is just bring it up finger tight at this point, just like take the slack out. So it's just pushing on it. Then we'll cinch that down and then readjust it after it runs. If it rattles a little bit, we can tighten it up a little bit. But that won't be today, it's going to be tomorrow because I got other things to do. And then we'll just cover this up and wait for tomorrow. And we'll get the head cover back on and the carbs in and the exhaust on. And we'll give her a fire up. So it'll be mere seconds for you and a day for me. All right, folks, I hereby decree that these will be the last clips on this abomination of a video. But we're pretty much good with this. I'm going to show you right now how it runs. Then I'm going to go over some detail and the things that I had to do off camera to make it so. So let's just cut to the chase. I'm going to set you up. I'm going to put the mic over another part of the garage here because it's just so loud. It overwhelms it. Might sound a little bit better for you. So let's go ahead and do that. And again, I'll cover the details and then we'll close this thing out. All right, as promised, let me go over real quick here what I did to get it to this stage of its running. And it is running really well. I'm real happy with the way it's running. Idle's good. I did synchronize the carbs up. These are very fiddly to do, but they are synchronized up as close as I can get them. The main problem we had as far as carbs go was both jetting and these carb holders. Let me start with that first. These carb holders, when I put them on yesterday, didn't look like they were sealing very well. These are adapters, actually. They call them 34 to 40 mil, something like that, adapters for these MKII flat slide, these radial carbs. And the overlap on the bore size of these carb holders, there's very little overlap with the aluminum openings of the head as far as the intake bores to those carb holders. Maybe 3.5 mil overlap. And as a result of that, this had compressed these from being on here for a while, and being that there's rubber on the back side here, it indented it and made a compression. And then when you put these on, I didn't like the way they look, so I put a flashlight and I could see light through them. So these things were not sealing when it came in here, which is probably why it hasn't been running worth shit. So I said, well, I'll just get another set of these. But they're almost 30 bucks a piece, probably a little over 30 a piece with shipping. And when I took a look at them, I said, if we just get new ones of these, it's going to happen again. So I decided to modify them, and it worked out really well. The back sides of these are aluminum, so essentially the rubber is molded to the aluminum. So I put these in the lathe and indicated them in, and then just faced the back of them, all 4 of them, one at a time. And I faced them just enough so it cleaned up the rubber that's on the aluminum, but luckily it left that rubber section, which is a perfect like O-ring, built-in O-ring almost, to go right up against the aluminum. Then I put a very light coat of Honda Bond HT on each one, and then Bob's your uncle, it's done, and those things sealed off really well. I think that is going to last forever because, well, until the rubber decides to decompensate, because there's no rubber on the mounting part of it anymore except the center section. Back here, up here where the bolt is, the cap bolt, and down here, that's aluminum and aluminum, so it's not going to go any further in. It's not going to loosen up. It's not going to do anything, and it's sealed up real well. The jetting was another thing I had to mess with. I'm 99% happy with the jetting, and I'll explain here briefly. The jetting that it came in with was 125s in the mains, which the customer said is what the carbs came with, and 17.5 in the slows, which is what I expected. So I ended up changing those when these carbs are off probably a month and a half ago, back to 120 because I thought 125 would be way too rich. I started it up, of course, today with the 120s, and it was like blowing black smoke. It would die as soon as you hit the throttle and the accelerator pump kicked in. It would just die. It would just completely die. And then when it didn't die, when you get it to kind of feather in and do that, then it blows black smoke out on the D-cell. So it's definitely rich. So I said, well, I got 115s and I got 110s. Let me try the 115s because you get 4 sets of jets with these carbs when you buy them. So I put the 115s in. You can do this with the carbs in situ because the way the caps are, the main jet's right up above the caps on the float balls. Put the 115s in. It was marginally better. It ran a little bit better, but it still blew black smoke. So I went to 110s, the only ones I had left. And that's what you saw it running in. It's 110s in the mains and the 17.5s in the slows. I think that's slightly a little lean for this thing when you're running it down the road. So I'm going to look and see if I have some 112.5s. If I don't have 112.5s in stock, I might order 4 of them and put 112.5s in. I think I'd be a little bit more comfortable with that than 110, but it definitely runs a lot better. Runs really well, actually, I think. Idle's good. Carbs, like I said, are synced, and I did check the ignition timing. So that's one thing that I took care of. Now, the other thing I took care of, there's 2 other things here, briefly. The other thing I took care of was, the reason why this is off is because of what I'm about to tell you about. Yesterday, I put the spark plugs in. No carbs on. Cranked it for a while. Make sure I wanted to hear what it cranked like under compression. And it started to grind and slip and like, you know, doing that sort of thing. And I said, what the hell? So I pulled the cover off, pulled the starter out. Starter looks good. Starter gear looks good. Hit the starter on a jumper battery. Sounds great. Pulled the cover off here for the dynamo cover, and then looked inside there. The gears look good. I said, this got to be a starter clutch problem. I look at the bolt on the end of the starter where it holds the rotor in, and the end of the bolt is all mangled. And I'm like, what in the hell is up with this? You couldn't even get a socket on it. I said, I got to take this off, because then what I found was when I looked inside the rotor, I found there's 3 cap bolts on the inside of the starter clutch that bolted to the rotor. 2 of the cap bolts were flush up to the inside, the threaded side. One of them was recessed. I reached in with a pick tool and I could actually turn that cap bolt. So one of those cap bolts was loose on the inside, sticking inwards. And I'm like, oh shit, what the hell is that hitting? And then when I took the cover off as well, I looked at the stator and there's only 2 cap bolts holding the stator in. And I'm like, oh my God, where's the 3rd one? Well, then you can see that there's a broken bolt in the bottom of the stator cover. So it's being held in by 2 cap bolts. That's probably okay because it registers anyway to a place inside there. I was like, you got to be shitting me that bolt inside there is loose. And by the way, the service manual says you're supposed to put Loctite on them. There was not Loctite on them because I ended up filing that nut, taking that nut off, pulling the rotor off. Finally, it was very hard to get off. And then taking and redoing those cap bolts on the back side. There was Loctite on the rotor bolt, which the service manual does not call for, but there was no Loctite on those 3 individual cap bolts that they do call for. I put it on there. I did put a little blue Loctite on the rotor. It's not a bad idea. It only gets torqued to 57 foot-pounds anyway. So that's another thing I took care of, but the springs in the starter clutch are no good that push the pins out. One of them was so shortened up from just being, you know, worn over years, probably heat and stuff. I stretched it out and it actually improved it a little bit. So I've ordered new springs and new pins. Before it leaves here, I'm going to essentially redo that starter clutch. The other thing I did today was when I first started it up, it sounded great. After it heated up for a while, it sounded like a freaking valve was about to fly out of this thing. And I go, what in the hell is going on? Well, I traced it down to an exhaust leak. I could stick my finger underneath number 4 here, and it was puffing out. And I'm like, I don't understand that. So it's very confusing. I did put new donuts in. Pull the header back off. The ring, or that flange around the end of this header, I didn't notice this when I put it on, it was actually cracked about halfway around the circumference. So I did a little bit of hot glue gun work over on with the header over on the vise on the bench, and got that where it's probably going to last forever now, but I would recommend a customer replace these at some point. So now it ain't leaking anymore, and now it doesn't sound like number 4 exhaust valve is about to launch into the stratosphere. So I'm real happy about that. So I had to fix that. I am going to fix this. I did that, and I did these, and that's what got us up to this point right here. And that's about where we're going to end this, because this video is way too freaking long as it is now. Couple of quick cleanup items on this outro. In the video where I fixed the threads on the cylinder block, I showed that I made new alignment pins for the cylinder head out of stainless. A couple of you guys commented that's not a good idea because of the way the stainless works in there, and whatever you said, I can't remember. So that was like 2 months ago, right? I actually ordered new pins for it. So this has brand new alignment pins right in here. So I did do that. So I appreciate the comments on that. The other thing I wanted to mention was during this video, because it's taken so long to do, I mentioned a couple of times at least, or maybe twice, about us being sick. We're doing a lot better. My wife's doing a lot better. And so we're pretty much on the mend as far as that bronchitis goes. Future me took the carbs off to get the head cover off, because you got to slide this one off backwards to get it out. And so I went ahead and checked the valve clearances again, because I've had 2 heat cycle runs. I've also retorqued the head bolts too, so that's another thing. But as far as the valve clearances go, the valve clearances were all still good, except for number 1 exhaust. Now that one was a little borderline tight anyway when I put it in. It was tight 4th thou. Still within tolerance, but I wanted it a little looser. So it had a 2.60 shim. I put a 2.55 in it, and that one's jives with all the other 7 now as well. So that's all done. Recheck the torques on the cam caps as well. Recheck the torques on the cap bolts that hold the upper tensioner in. Everything's still tight. Put it all back together, and the carbs are going to stay off till I rejet it. So I just wanted to mention that at this point, toward the end of this abomination of a video, that I did do that. My time is done on this, and so is this job pretty much. I'm going to finish up any last minute stuff. I want to rework the fuel delivery as far as the fuel hose. I didn't like the way that was when it came in. I'll get all that done, get the tank back on, and off camera I'll take it for a shake up and down the road, see how it goes. But I think I'm going to work on changing those jets out to 112.5. The more I think about it, the more I say it out loud, the more it sounds good to me. So I hope you got something out of this video. I know it's super long. I normally don't do videos this long, but this thing has just been going on forever and ever and ever, and I just really wanted to get it out of here as far as the content goes, and get this out of here too. And it's just about there. So if you like what you saw, you know what you need to do. You stick around. If you're not already brain damaged from watching this debauchery of a video, and then you get notified when I put more stuff up. If you do the ringing of the bell and do all that crap with subscribing and stuff, you know what to do. You're smart. So until that next time, as always, thanks for watching. Don't just repair, restore. We'll catch you on the next video.